On this one, I wanted to talk a little bit about refrigeration oils. Those are the oils that are used in our refrigeration applications. The oil we use in these things can be of several different types. There's mineral oil, there's PO, there's PAG. PO and PAG I'll talk about on a different video, but I wanted to start out with mineral oil. This is mineral oil. Now, I'm not going to drink it. I don't think it's really very good. But what is mineral oil? It's derived from petroleum. So it's dug out of the ground. And then by distillation, it's produced. And I'm not going to go into any of the basics of all that stuff, but it's a refined product out of the ground. And with a few exceptions, compressors have to have some sort of lubrication system to ease the movement of the rotating parts and to take heat away from different components. And there's three types in general. There's mineral oil, there's PO, and there's PAG. PO and PAG I'm going to talk about in a different video. But this one's just going to be about mineral oils and general usage. I'm certainly not going to get really deep into how oils are made or how they're, what the properties are to make them the best oil and so on. None of that's going to be in here. This is just general use for the service tech. Okay, mineral oils, which we don't use a lot of anymore. Most systems use PO or PAG, but that has to do with the type of refrigerant that they're using. For CFCs and HCFCs, that would be R12, R22, R500. Those are all pretty much gone now. But they all use mineral oils. So why did they use mineral oils, and what is mineral oil? Well, mineral oil is dug out of the ground. It's petroleum dug out of the ground. The distillation process produces a lubricating type of oil. And that's what was used. Now, why was it used? Because CFCs and HCFCs mixed well with it. It's called miscibility. I call it mixability. Refrigerants like the CFCs and HCFCs are solvents. In fact, we used to have the old R11. That's what it was used for. It was a solvent. It boiled at like 70 or 80 degrees, so you could use it for cleaning parts. We actually flushed out systems with it. There's a type we use now for flushing out systems that's safer, but they mix kind of like oil would mix with gasoline. So because they mixed well, that made them good for compressor applications, refrigeration applications. Because all compressors pump oil. That means when they're during their normal operation, some oil will be removed from the compressor and go out the discharge line. This is normal for them to do. In fact, they kind of have to keep up enough lubrication. In some cases, like an air compressor for a shop, we want as little as possible because we have to then replace that oil. But in refrigeration systems, that's not true. Because they're a sealed system, if oil is pumped out of the compressor, then it also comes back to the compressor under the right circumstances. So if I'm operating a refrigeration machine and I'm using the lubricating oil to ease the movement of parts and move away heat, those are the two things it does, then if it mixes with the refrigerant. When the refrigerant's a liquid, that makes it a lot easier to get it to come back to the compressor. Because if it just pumped out of the compressor, then all the oil would be out in the system and the compressor would dry out and it would destroy the compressor. So we have various ways of getting oil moving through this system. Now, the refrigerant comes out of the compressor as a gas. It's called hot gas. The oil is mixed in with it. Then it's condensed in the condenser. When it condenses in the condenser, like any solvent, it mixes with the refrigerant. So the refrigerant and oil are mixed together. Then it can just move through the system. It moves through the rest of the condenser, then to the evaporator. There it evaporates. Now here's where we have a little bit of a problem with oil. It doesn't always want to come back unless the conditions are right. So when we turn it into a gas, the refrigerant goes from a liquid to a gas, but the oil stays as oil. So as it's moving through, we need that gaseous refrigerant to be dense enough to bring the oil back with it. Okay? So as it goes through the evaporator, and at the end of the evaporator, it all becomes a gas, the refrigerant does, then you want enough velocity, enough density of gaseous refrigerant to drag the oil with it back to the compressor, and it goes through the cycle again. So as long as we have a refrigerant that mixes well with oil, and we have enough density in the system to move that oil through, then we keep oil in the compressor, and it doesn't get out in the system. Now, a couple of things can happen here. If the unit's low on charge, then the returning gas is not dense enough, so oftentimes it doesn't bring the oil back. If it doesn't bring the oil back, you take the chance of the compressor seizing because of lack of lubrication, especially if you have a long suction line. A long suction line may, if the gas is not dense enough, then there may be low spots, and it'll just stay there and won't come back. TXV adjustments, superheat adjustments are necessary to make sure that we have that density. Sometimes if it's maladjusted, then it'll feed too little, the superheat will be too high, and the gas will not be dense enough, and it won't come back to the compressor. All these things are going on, but this is what mineral oil, its value is in that it mixes with refrigerant and is easily gotten back. The viscosities are correct and everything that can be gotten back to the compressor. Now, I talked a little bit about the miscibility of oil and refrigerant. Now remember, when refrigerant and oil mix as liquids, the solvent in the refrigerant tends to thin the viscosity of the oil. So let's say we had too much refrigerant in the system, then liquid would be coming back to the compressors. Well, one of the reactions here is that it's going to thin the oil, and then its lubrication is not as good. It can also foam the oil because the suction of the compressor sucks on the oil level, and it looks like it's boiling, but it's not. It's just the refrigerant that was mixed with the oil is coming out of it. It makes quite the foam. These can be pretty spectacular, and they can cause slugging of the compressor if it's a piston compressor. So oil's important here, and it has to have certain properties to make it work with the system. there is a balance of getting all these things right so that that oil moves through the system as it should. Some cases you could have, say, a condensing unit on a roof and evaporator way down low, and then it has to come way up several stories to get the oil back. Well, then we have a problem there, because the higher it is, the harder it is to get the oil to come back completely. And so sometimes we'll put traps in the line, a little trap like that, so that the gaseous refrigerant has to bubble through the oil and pull it back up with it. There's all sorts of things like that we sometimes do. Mineral oil also has to be able to handle the different temperatures. Certainly the high temperatures it has to handle. It has to handle sometimes low temperatures. If we are a very cold box, then it has to keep its viscosity in the right range so that it will provide lubrication as it should at low temperatures. Sometimes there's temperature-related miscibility, where it doesn't mix as well at certain temperatures. All these things have to work together for this oil to do its job and the machine to last. So there's a number of jobs that this oil has always had to do. And when we started changing refrigerants from the old CFCs and HCFCs, we found that the refrigerants that we were developing did not work well with mineral oils. So we've had to change to POs and PAGs to work with the new refrigerants. In some cases, like in R134A, if you used mineral oil and there was some residue left in the system, and then put 134A in it, and the oil for 134A, which is a PAG, then the two oils didn't like each other, and they would make kind of a sludge. So there's things like that happen, and we'll talk about that in the next video. But refrigeration oils can be one of the most important parts of a refrigeration system, because the oil will determine on how long the machine lasts. One other issue with oils, as they pump out of the compressor, we kind of want to limit how much they pump out of the compressor, because the more oil that circulates with the refrigerant, the less refrigerating capacity you have. Because if there's a large amount of oil moving with the refrigerant, it contributes nothing towards refrigeration. And so we like it to be lower, as low as we can get it. Now, some compressor systems, I'm not sure that's always true. With the scrolls, they tend to move an awful lot of oil. And I think that's for the lubrication of the scrolls. So they need to actually move a fair amount of oil through the system. And the system has to be designed so that that oil will come back. Okay, next one will be on PO and PAG, and we'll talk about the differences for those two. That's it on this one.